Hi, everyone. Thank you for coming to this session today. I'm really happy to be here, and it's been great to see everyone in the last few days and hear what everyone else is working on. So today I'm going to talk about assessment design and how we can use the design to eliminate the need for proctoring or observing students. So my name is Mary Ellen Wiltrout from MIT. I'm in the Department of Biology, but I'm a lecturer in digital learning and a director of online and blended learning initiatives. And so I had my start in MOOCs way back when really edX was starting everything. So I was part of the team that created the first Introduction to Biology course on edX.org, and that course is with Eric Lander. And so if you look at this picture here, you can see the faces of all the certificate earners from that first run of the course. So that's how I got started a long time ago. And I'm also part of this digital learning lab at MIT. So when we were creating these early MOOCs, a group of us met with each other and just had lunch together because we realized we have these same things to talk about and nobody else really understands what we're working on. And so we met and formed a group, an unofficial group. And then over time, we called it the Digital Learning Lab. And it eventually got recognized by President Reif at MIT. And so this group is across all departments at MIT, and so they have expertise in a discipline, and then they're the ones who are working on MOOCs or blended learning within the department. So just to give you some background, because the model is a little bit different from other schools, is that the people come into this discipline with discipline expertise and teaching background. So when they come into this job, and then they're gaining expertise and technology like the Open edX platform, or management of projects, or application of the learning sciences. They're also maybe working on research and data analytics. Or design of courses in general. But one key thing is that they also have other soft skills or power skills that are right for the job. They have to work with a lot of different people, understand learners. And so there's also this idea of just being change agents for departments. And so especially in 2013, that was really important to have that attitude and have the right people skills, and it's really important to have a growth mindset, just like we heard this morning, of always learning something new within technology or what is coming out in education research. So these competencies all fit within a concept similar to learning engineering, and there was a paper at MIT written calling the Digital Learning Lab members learning engineers, and this is a concept that came from Carnegie Mellon a long time ago. So today's questions, what I want to focus on is how do we approach the assessment and learning in MOOCs or blended learning experiences that allow for scalability, but allow for assessment design based on evidence, but also it takes into account the trust in the certification. We also want to talk about what evidence do we have about this assessment design and the choices we make. So let's first review the goals of our MOOC learners. So they're there just generally to learn, but we also have students that are really just exploring. So they're not the same as the MIT students that are on campus enrolled in something they have to complete it for a degree. We have students who are just there for entertainment, like Netflix, and they're using it that way. We have students who are there for connection, for social connection. So they're learners who are, they want to see other learners on the forum. They just want to know they're in a space where other people are. And especially during the last 2 years, that's been important. And a lot of people are really using our MOOCs for elevating their career status or for maybe an application for school as well. So with that last point, that really means that a lot of learners want to earn a certificate. And if they want to earn a certificate, then that brings in more pressures than the learners who are there just to explore. So next, I'm going to go back in time too to when there were several papers that came out from groups around MIT on cheating in MOOCs. And so one issue with MOOCs being so accessible is that then it's easy for people to have multiple accounts. And so the cheating involved multiple accounts. So, get answers from each other. And so the prevalence was up to 10% of certificate earners, depending on the course they were looking at. And these are numbers back in 2016 and 17. And with, the motivation really is just for students to take the easy path and not really put in the effort, because MIT courses are pretty hard to finish and complete. So we already knew from their early work and just my experience in running the courses teaching and learning. And in emergency remote teaching and learning, so many people ask the question, how do we assess teaching and learning online? And, even more specifically, a lot of people were like, well, how am I going to give my exam online? And then with that exam came a lot of concerns of, well, how do I trust the students to do this at home? How are we going to trust that they're not working together or using other resources? And then that came the increase of proctoring services, or even a lot of people just using the free route of watching their students online over Zoom, just in a way that they thought they were preventing cheating. But obviously students are pretty smart and can get around any of those methods. And so instead of focusing on the policing and then even once you do catch people, there's a lot of work you have to do after the fact to then approach the student and deal with the case. And instead of that approach, I'd rather, over time, we've taken the approach of just prevent it in the design, and then you don't have to put all this effort in after the fact. And also it shows that you trust the students versus the way of trying to catch them. So what I'm going to talk about today is this course design that we call the competency exam model. And in the competency exam model, we have the course materials that are set up for learning, so that we could set those in the types of modes that are best for learning. So when I mentioned before, we're not giving feedback, that's not the best thing and not the best way for learning. So it's all backed with the learning sciences and the way we set this up. There are many formative assessments. So when Daniel talked the other day, they mentioned how large the MIT courses are, so easily hundreds of individual problems that learners are doing for formative assessments. These are all self-paced, so they can do it whenever they want over a several-month period. They're not counting in the grading policy for this specific case in this course I'm talking about here, so it's all just graded and scored, but not counting towards the grading policy. And there's feedback, so correctness feedback, but also more elaborated feedback of, why is this answer this answer? And for this case, we're using the old course, and this was a pivot point in 2015 where we decided to use all the old course materials as the materials for learning. So there are problem sets, exams, videos, everything that was there, and that's what we're using as the learning materials. So with the design of applying the learning sciences, you can look up this paper here where we present this framework and how we generally approach design in MOOCs. And specifically, this graphic, it's interactive. So if you do go to this link, you can play with it, and you don't even have to read the full paper. You could just play around with it. And so with this framework, on the inner circle are the course assets. So we have the goals and objectives that we give students, the image handouts, there's the multimedia in yellow, like videos or images, the supporting resources like the forum, and the formative assessments and summative assessments that I'll talk about more today. And so on the outer circle are the learning science principles that we use. And so you may recognize something like multimedia learning theory that we apply to video or image use. We also have concrete examples that apply to motivating students, and things like activating prior knowledge, authentic assessment, low stakes assessments, and scaffolding that we apply. And then when we talk about formative assessments like problem sets, then problem sets for every asset category, we have then the linking types of learning sciences that apply to that asset. So Bloom's taxonomy, scaffolding in this case, concrete examples, authentic learning. And so it's a lot, you'll get a lot more detail if you go to the link and then play around with it if you want to see more. So in our courses, we use a structure that many people have adopted now, where we have short videos and then questions immediately after. So here's an example of how we have a short video, and then right after there's a question about this experiment, and it's not what was necessarily right in the video, but a different setup of the experiment, how you would use it, and then a short question that they have to answer. And so those are formative assessments. They just for practice learn quickly in the moment. And then we have formative assessments that are a little bit longer, like problem sets or quizzes, and they may be multiple pages with multiple problems in every page. And so in these, the questions will get a little bit harder. In this example, I'm just showing that there's a structure here, but there's no name of that structure. The students have never seen this structure before. There's not really a way to look this up. And so asking a question about features of the structure. And then in this point, I'm showing that when they get the answer, they can also get elaborated feedback. And this extra feedback is not just telling the answer is 11, but how do you get to 11? And so with the circling of this image, then you can show, here's what you should be looking for in this question. All right, so here I want to show an example of what I mean by how can you do authentic experiences in a biology course, without physical organisms. So in this case, we have become more computational with DNA sequencing. And so now we gave MOOC students the full gene of sequences for multiple genes, so they can scroll through the DNA sequence. They can click on specific areas to see what is happening in that region. And then this also leaves us with thousands and thousands of questions to ask. We can ask about any nucleotide in the sequence. Say, what if you change this nucleotide? What would that change in the resulting amino acid sequence in the protein? And how would that affect the outcome of the functionality of this protein? So that's one example of authentic, because researchers, we got this from the researchers in the Broad of what they use. So the other feature or aspect of the design of this competency exam model is in the question creation itself. So it definitely takes a team of people, and the people are trained in biology. Either they were, already had PhDs, or they were graduate students studying to be biologists. And so we have in this exam around 100 questions that students complete. And they're distributed across Bloom's taxonomy, so easy recall level the whole way up to more application, and then even beyond that. And then in this exam, we really wanted to be more like mastery, not that they just that one night crammed and were able to do something, but really they can show that they know this material from this entire course, not just parts of it. So here's an example from a summative assessment. So the competency exam is really an example of summative, meaning it's coming at the end of some larger learning experience. And now we want to test for mastery. And so this is just another example of how we have a DNA sequence here, but we're asking students to do this translation step and then give us the code, and it's text input here of them being able to input the answer. And so did we have better learning objective coverage in this kind of exam than our older models? So here I'm showing that with the final exam that from 1 year on campus that other people wrote, there were it was about 10% coverage with of all the learning objectives for the course, versus all the exams even for that semester, it was 27%. And then in the MOOC, the original MOOC, it was kind of similar because we were using a lot of the model of what was done on campus. And then in this Competency exam, though, we have 61% coverage. One is just because we can make it longer. And two is just because we're actually mapping the learning objectives and not, there's a lot of questions that are just easy to always ask about. And so we're avoiding the repeating of the same things always being asked too. And so if we look at then the levels of blooms that were in these same types of questions too, that all the questions on campus or in the MOOC or in the competency exam kind of have the same pattern where there's a lot of application. There's definitely remembering and understanding, but we also have some that get into analyze, evaluate, and create. So we were pretty happy with the original design that it seemed like it would be an improvement from past cases. So then focusing on the design in the platform of how we can make cheating require more effort, and so then it wouldn't be as tempting for students to even try or think about. And so we can use a lot of security features with this, and so we have it available for one specific week versus the other course materials are always open for a long period of time. And in that week, they have flexibility of what day they want to take it. But once they decide the day, then it's timed once they start it. It's verified track access only. So I think we are one of the first courses to do this, verified track access only on edX.org. There's an honor code or warning at the beginning that they have to sign off on. And so there's a paper there as well, like just showing that just simply adding honor code to exams deters cheating. We use prerequisites that I'll explain in a little bit more detail here. There's randomization per multiple part question. And in that case, I'm not using a content library I like to pull problems from. I'll show you in a minute what I do. There's no feedback on correctness, and so when we originally did this, it was not easy like it is now to just click some buttons. We had to have extra code that we added to every individual problem, and given that we have randomization, it was 400 or 500 problems we added this code to. So there's no access to the exam after they complete, so they can't share it with someone later. And during the window of that 1 week only, then we shut the discussion forum off and we tell them there's an email to contact staff if you have any problems or a question about something, but don't put it in the public forum. And it's shut off anyway on the edX side. So this exam is made up of 2 parts, and now a lot of these features are kind of probably regularly used in edX, and so many people may have tried it who are here. And so we used the prerequisite feature. So if you haven't used this before, so you can see first it's under the advanced settings in Studio, and then you go to timed, you can set your timing, but then below that it's limit access, and limit access means the prerequisite feature. You can say what part do you want to have them complete before you move on. And in this case, it's the required tasks, so that's where the honor code or cheating warning is given. So they have to agree to that and get 100% correct before they move on. And the other way we use prerequisites in this case is that we don't even give access to the second part of the exam unless they score high enough on the first part. So if they score high enough to possibly pass, then they can keep going on, but they just don't even get the second half unlocked if it's not high enough on the first part when they're trying. All right, so this may be unique that we use split test, the A/B testing in edX to do randomization. And the reason for that is because we want a submit button after each problem. but we also want an entire page of questions that are related in some sort of story fashion to be randomized. And so in this video, you can see that the questions look the same, but that but actually the answers are different in every case. So if people were just, trying to compare, it may seem like the same question, but it's different. And these are randomized, so there's 4 groups. So on every page, they're getting a different group on every page. So even if 2 students had the same on problem 1, by problem 2, they would have a different group from each other. All right, and then for the student view, it looks like this. The students don't have group A, B, C, or D at the top, but I'm just showing you the student view. I still use legacy drag and drop, so that's what that is at the bottom. And then you can, as an instructor, go through A, B, C, D, and look at the different views of what students would see. Right, and so I'm just showing now the last part and what they have to do in this sort of question. And it looks very similar, but would have a different outcome than the other problems. All right, so does the CE model reduce the amount of cheating? And so a few years ago, we did, we actually wanted to measure this, and we looked with collaborators. We looked at 5 consecutive course runs of either not having the competency exam model or having the competency exam model. And we looked at the population of learners who were certificate earners. And then we were using this method that really has emerged from the older studies that they had, but really now it's just modernized a little bit more for looking at anomalies in the detection. So I'll just show you what type of anomaly detection here is. That it's looking for a footprint in the data indicating some sort of abnormal behavior, either with time or performance on the assessment questions. And then the level of these types of error measurements then correlate with the amount of cheating. And there's some references there to the development of these techniques. And so with our course model, we looked at these different course runs, and you can see there's a lot more abnormalities with the performance behavior when we didn't have the CE model versus after the CE model. And then if you look at the time patterns, they also were more abnormal before than once we had the competency exam model. So this indicates that there's less or almost no cheating, or at least aberrant behavior. So I just wanted to mention, in the context of the pandemic, of like some other work that we did that may somewhat relate to this, is just looking at engagement within the MOOCs during the pandemic. And so we saw, of course, things changing. So here's Katie Blackwell that did this work with me, and she was an undergrad at the time, and now she's a grad student at MIT. And we saw that the percent learners, the 2019, they're pretty consistent, and in the course runs, a consistent amount of learners. But in March 2020, we definitely had a very big jump in 2020 for this course. And then by the July 2020 run, it started coming down. But what we wanted to know really is by a percentage, not just the number. So these are the number percentage of learners participating. So they clicked in or viewed at least once. And it definitely already started going down by the July point. And so overall in this study, we could see that more verify but less certify. So what that means is that the participants that were on the verified track went up in number, and as a percentage that also went up in number out of the total. The percent certified on the verified track went down. So the people who were actually completing, the number was roughly, higher than some older runs, but the percent overall who certified went down. And then I also wanted to highlight that in this course especially, we see that there's students who register for the verified track but never even attempt the exam. So I want to just as taking out that data. And when you look at that, then the percent who actually certify at the end of the verified track is around 45%. And the percentage then went down by the July 2020 run. So there was, even though more were involved in July 2020, there's definitely fatigue that was there. And we saw that there were more EDU email addresses during this time, but that didn't mean that there was, like, even though there's more pressure, this is for credit, but they're not necessarily, because edX, there were definitely groups from one school coming in, so we expect they were probably for credit, but they're not necessarily seeing signs of more cheating or more certification happening during that time. And in the other question then, were students really cheating more in the last 2 years? Do we have any evidence of this? And another former MIT person, Chen, he's in Florida now and looked at his students, and so he already had experience designing online physics questions. And when he looked and used similar methods that we just mentioned, he didn't see indications that the learners in his course, the students in his courses were the cheating in his course. So you could check out that paper if you want to look into that more. All right, so with that, the main message is just to trust students more, and especially during the last 2 years, just have that sort of sense and attitude. Apply the learning sciences as you work on assessments. Evaluate the assessments as you build. So, in the early stages, we're looking at what we designed and evaluating it from the instructor point of view, but also evaluate it from beta testing. We definitely did many rounds of beta testing and then changing before it ever released. The course design from our data indicate that it definitely does influence cheating and really prevention of that. So I just wanted to highlight, use the edX features creatively, because earlier Ignacio mentioned he wanted to have passwords. And so we've done that already with using the prereq feature. So you can just give the students in a room a group code and say, only if they get this right, then they can unlock the exam. So it's already possible if you want to, with not too much effort, but not obvious to general teachers everywhere. And with the split test, that I don't know if anyone else uses that for randomization than us. So, and then the upfront work and design effort definitely took time. It's not that it's easy. It definitely takes people with expertise in the discipline, but it was worth it because we can reuse this exam over and over again and not really worry about it. It's worth it on the end of, we're not really worried, are they, really earning this or understanding it or knowing it? We need to scale because we have a lot of MOOCs in our department and we are running them over and over and over again. So we can't spend time really focusing on one course or rewriting one course over and over again. We need to create courses that can last a long time. And so we think the work is worth it. So with that, I'll leave it for discussion and questions because, I'm curious to hear what other things all of you struggle with designing assessments, or what other solutions you may have as well.
Hi, great work. Congratulations for that. I wanted to hear a little bit more about the configurations of the randomization process, because for me it wasn't too clear. However, I think that's really a good work that you've guys done. Congratulations.
So in advanced settings, did you do split test in that area And then when you're saying the configurations, are you having trouble setting up the split test and the randomization? Okay. Yeah. I can show you in more detail too of like what it looks like, but basically then it creates another layer. So when you go into the page to edit it, then you have to edit, like click again to go into groups, and then you say how many groups do you want. And in our case, we said we wanted 4, and they're automatically labeled A, B, C, D. So what we did then, we would design one problem and say, okay, this is the master problem, and have in mind what would be possible to randomize, not something where there's really only one version. So things like DNA sequence, like I mentioned before, is really easy because we can change the sequence, or we can change what region of the sequence we're adding or asking about. There's others where we had like that table you saw, and so we could have different rows in that table for different students, and even though it still looks like a table. And so that requires a lot of creative thinking of like what is randomizable and what is like really just one straight problem. And then thinking about using like a constant image, but it would be reusable in some way versus creating many images. So in each group then, it's the same building process of like add a problem, add a problem, add a problem, design what you want in those problems. And then, you know, we could just copy the problem and then tweak it. If it's something simple, maybe we had like build it again otherwise. And then you have your 4 groups, and then for when the learners enter, it will, you know, decide what group that learner's getting. You don't have to do anything on that end. It's automatic.
Well, thank you very much for your presentation. We used to do a manual randomization in the past with the assignment of cohorts to different models of exams. With your approach of the split test, well, I understand that you try to minimize the differences of the different models of exams in the grade or in the difficulty level per student. Is this correct? I haven't used the split test, no, so.
Yeah, so some advantages are that like it looks the same. So even if we use it with MIT students, and we did use this kind of testing with MIT students, and they're in the same room, then if you're sitting behind the people in front of you, you look like, oh, that person's answering this, and you go ahead and put it in because it's going to be wrong. So there's that advantage, but then we also want to worry about like, it is, you know, we want to be as fair as possible so everyone's getting a similar exam. It is possible that some may be a little bit harder, but we can look at the data on the other end of like, is there some version that seems to be really off? But trying to keep it as similar as possible, and within the questions, like trying to judge. And so when we had beta testing, we could say like, you know, if somebody was getting it wrong, was it really a hard question, and why did others get it right and that one person got it wrong? You know, did they get a version that was somehow harder? Thanks.
Thank you. Thank you for that awesome talk. I wanted to ask about a couple specific items. I think they're related to both related to prerequisites, but I'd love some clarity. One was you provided a code to students in the rooms or within the class who could unlock the exam, and that was specific probably per run or per course, right?
For MIT students when we did it in the room with them.
Okay, and then they did it with MIT students in the room with them. So for the record, and then in terms of like students that didn't do well in the first part of the exam and couldn't unlock part 2, what happened there? Was there any remediation to that?
Yeah, so it is unfortunate when they don't pass and can't go on, because some are like, why can't I unlock? Because they also don't know their score. They, you know, so some that may be close, that's the hardest situation, and I get an email from them. But for the others, it's not that many that are really like close and at the border. For others, I think there is some of like, I want to just check this out and maybe pass again in the future. And I think there's some who are like way underprepared, but because we have the learning materials self-paced, then there are the people who want to cram and then just try the test. And then I think those are the ones that really they're getting 20, 30%, they know they're not going to pass, so it's not even worth continuing on, or they may have just looked at the first 2 pages and quit. And so they don't really complain either. And so the remediation is like, we really try to encourage them, don't sign up for verified track until you're ready to take this, and just the course is always running year long. So take the next version if you didn't have time this time. Keep studying until you're ready. But there are these like tricky cases where somebody is close and they're not too happy they were close.
Okay. I'd like to understand how you define cheating. Is it about someone else doing the exam for you, or just looking at someone else's computer, or what is cheating? And as you define it, then what is your idea why it changed with that approach?
Yeah, so I think what is cheating can be a lot of answers, and in this case, we can take into account those. In the beginning, I started with some previous research with multiple accounts in MOOCs. So when students have different email addresses, there's also the case where they have done studies where it's 2 different users submitting answers like at the same time and could tell that. So those are like the ones we have data on, like there's definitely this type of research, but I think even if there's other interactions, like looking up a lot of information from other people that are not involved even in the MOOC, and that would just take extra time, and then it would come up in the aberrant behavior, the odd behavior that they're trying to detect with the statistics. So either like with time or performance, it'll come up as looking odd, even if it's for other reasons. And so we want to just focus on trying to apply all the methods so that they're additive, versus it being like, okay, we already have data and research and papers that show like just adding honor codes and warnings work. We already know that just not providing feedback works from another study, and they're just doing one method. So if we do all of these methods in one place, then it makes it pretty hard to try to efficiently cheat.
I was wondering if you had any pro tips for questions that aren't easily randomizable, how you approach this.
Yeah, I think it's really hard even in the beginning when we just talked to faculty about having online questions and having them computer graded. They're like, we can't ask this question. We have to have them write letters. I'm like, no, we can have that being graded by a computer. And so it's just a different way of thinking. And so I think having the experience with the platform and knowing what the problem types are, and knowing that, in biology, we can use images in the platform and have people either click on things or draw things, and you can have them create an image even with the drag and drop. So people don't realize that. They're like, you can't draw in an online course, so it's not possible. So I think whatever it is possible. It's just having creativity to get there. We have a lot of programming courses and everything too, and so there's ways to randomize. Of course, our math and physics people are more at advantage of just using random number generators and those sort of things too.
One of the things I found most interesting was the way you said, we're talking about how you used some of the existing behavior in like creative ways. I was curious, do you have like a dream feature that could be added to sort of support your the testing methodology?
Well, I wish you were employed in 2015 when I was trying to do this, and I had to argue with why I wanted these features. And so, but at this point now, I've figured out a system, and as a team, we've been making this work. And so I don't have like this one sticking point and one thing that I really need at this point, but I also didn't come prepared with that answer. So, I mean, if you ask MIT people that question, you will have a list of 100 things by tomorrow. So I can share that with the group, and we can have the list for you.
I'm willing to answer the question, to be honest. Because you showed already prerequisites, and what we to also connect to Ben, what he's asking, like we did some experiments with also similar to what MIT is doing, with exams in there, but also like to give students the opportunity to redo an exam and then continue. Only the problem in there is like prerequisites, you can only select one previous subsection to be a prerequisite. So if that could be multiple, that would save us a ton of work and gives us more opportunities. So that is very high on the list, to be honest. I can also cover 1,000, but I will.
All right. Thank you, Mary Ellen.